Hello everybody, how are you? Hope you are doing very well. Today inshallah we'll start a new module I, unit number 1, lesson number 1, which will be about motion and speed. So how can you describe the location of an object? So guys, have you ever gotten lost while looking for a specific place? If so, you probably know that the description of the location can be very important. So imagine that you are trying to describe your location to a friend. So how would you explain where you are? Actually, you need two pieces of information. First, a position and a reference point. So actually, position describes the location of an object. So often you describe where something is by comparing its position with where you currently are. For example, you might say that a classmate sitting next to you is 2 desks to your right, or that a mailbox is 2 blocks south of where you live. So here, each time you identify the position of an object, you are comparing the location of the object with the location of another object or place. But when you describe a position by comparing it to the location of another object or place, you are using a reference point. So a reference point is a location to which you compare other locations. So, for example, imagine that you are at a zoo with some friends. If you are using this map here, you could describe your destination using different reference points. Using yourself as the reference point, you might say that the red panda house, for example, is 1 block east and 3 blocks north of your current location. Or you might say the red panda house is 1 block north and 1 block east of the fountain. So here in this example, the fountain is your reference point. So guys, what is motion? An object moves or is in motion when it changes its position relative to a reference point. So motion is what? Motion is a change in position over time, and even when motion is not observed directly, starting points and end points can indicate motion has occurred. So what about distance, guys? How is distance measured? Distance can be measured actually by 2 ways. First of all, it can be measured as a straight line between 2 positions. So suppose we have here position A and position B, and you are moving from position A to position B. So guys, here we can measure the distance by a straight line that will go directly from A to B this way. What about the other way, guys, by which we can measure distance? Distance can also be measured as the total length of a certain path between 2 positions. So for example, we have this path. You may follow this path from A to B, or you may follow another path from here to here to here, and so on. So here we can have several paths, right? So anyway, as we said, the distance can be measured either as a straight line between A or B, or as the total length of a certain path between 2 positions. So guys, for example here, what do you think? Which distance is greater? A straight line from A to B, or the total length of the path below? So I will leave the answer for you. And here, guys, we don't have like correct or wrong answer. All the answers will be correct, since we are estimating. But later inshallah we will know how to measure the distance exactly. Okay. So guys, what is speed? Actually, a change in an object's position tells us that motion took place, but it doesn't tell us how quickly the object changed position. So The speed of an object is what is a measure of how far something moves in a given amount of time. In other words, speed measures how quickly or slowly the object changes position. In the same amount of time, a faster object would move farther than a slower moving object would. So today, guys, inshallah, in our lesson we will learn about two different kind of speed: average speed and the constant speed, and how to measure or calculate the average speed, or how to measure or calculate the constant speed. So guys, let us start with the average speed. What is average speed? So actually the speed of an object is rarely constant. For example, the biker may travel quickly when he begins the race, but then he may slow down as he gets tired at the end of the race. So average speed is a way to calculate the speed of an object that may not always be moving at a constant speed. Instead of describing the speed of an object at an exact moment in time, average speed describes the speed over a stretch of time. So if two objects travel the same distance, the object that takes less time has a greater speed, of course. An object with a greater speed travels farther in the same time than an object with a lower speed travels, as we said. And guys, what about the standard unit that we use for speed? The standard unit for speed is meters per second. So because we usually, as we said, we use the unit meters for distance, and the standard international unit that we use for time is second. So the standard unit for speed is meters per second. And from here, from this unit, we can know the rules, or the rule that we use to measure the speed. So speed actually is equal to what? Speed is equal to distance over time. So S is equal to D over T. So guys, let us try to answer this question together. A penguin swimming underwater goes 20 meters in 8 seconds. So what is its average speed? So here we need to calculate the average speed. Okay, what known values do we have here in our problem, guys? We have the distance, which is equal to 20 meters. So we have the distance. What else we have? Yes, we have the time. So distance, which will be represented by small d, as I will show you here. So guys, distance is equal to should be small, as we said, 20 meters. What about the time? T is equal to what? 8 seconds. So this is our known value, and we need to what? We need to find out the average speed. So we need to find out the value of S. Speed. Okay. So as we said, the formula that we'll use is so simple. S, or speed, is equal to what, guys? Speed is equal to distance over time. So here, distance over, okay, we may use this, guys. So as you can see here, this is our formula that we will use to measure the average speed. Speed is equal to distance over time. So now we need just to substitute the values that we have into the formula, to this formula. So the distance is equal to 20 meters. Okay, and time is equal to 8. So you need to substitute here by 8 seconds, and then using the calculator, the answer will be what? The answer will equal 2.5. Okay, so 20 meter over 8 seconds. The speed will be 2.5. What about the unit, guys? 2.5 meters per second, as we say. Okay, so this is our final answer. The average speed will be 2.5 meter per second. Okay, so how is the constant speed graphed? Distance time graphs are used to plot the distance an object travels over time. So the distance of an object away from a reference point is plotted on the y-axis, while time is plotted on the x-axis, as we can see here. Guys, this is our distance time graph, and we always will plot distance on which axis? Yeah, on the y-axis, while the time will be plotted on the x-axis. So guys, so objects moving at a constant speed make a straight line on the graph, while if objects are moving at a changing speed, then we will not have a straight line. So we will discuss about the graph of the changing speed later, but right now let us see what is the advantage actually of the constant speed graph and how can we use it, guys. The slope or a steepness of the line is equal to the average speed of the object. So we can, guys, find out the speed of an object either using the formula that we have learned, which is s equal to d over t, or just we can find out the speed out from what? Out from the graph. Okay, so again, the slope or the steepness of the line is equal to what? Is equal to the average speed of the object. Okay, so how can we find out the value of the slope? Average speed can be calculated by dividing the change in distance by the change in time for that time interval. So again, in another word, slope is equal to change in y over change in x, and we say that y represents what? The change in distance, while x represents what? The change in time. So guys, let us try to analyze this graph, the distance time graph we have here. We can see that the this object is moving between these 2 points. Suppose this is A and this is B. So the value of x right here is equal to 5, as we know, while the value of y is equal to 70. Exactly like in the middle between 60 and 80. Okay, so what about point B? The value of x here is equal to 10, as we can see here, while the value of y is equal to 140. So what is the meaning of these values, guys? It means that the ostrich here start at which time? At 5 seconds. Start is moving, and at this time the distance was 70, and then it start to increase its distance, so it moved from 70 to 140 meters within 5 seconds, as we can see here. Okay, so now we need to find out what the speed of this ostrich, guys. So the speed here, if we need to calculate the speed using the graph, as we said, we need to find out the slope of the straight line. Okay, so slope, as we said, is equal to what? Change in y over change in x. So x will be here 5 and it changed it to 10, while y will be 70 and it changed it to 140. So change in y over change in the x values. Okay, so it will be as following, guys. 140 meters, subtract 70 over 10 seconds, minus 5 seconds. Okay, so the final answer will be 14 meters per second. So guys, this is how the constant speed graphed. Again, as we said, we will plot distance and time. The distance will be plotted on the y-axis, time will be plotted on the x-axis, and as we said here from the graph, you can see a straight line, which means that this object is moving on a constant speed. Okay, so guys, now let us see how changing speeds graphed. Okay, so on a distance line graph, a change in the slope of a line indicates what? Indicates a change in speed. If the line gets steeper, the object speed has increased, while if the line gets less steep, the object has slowed down. Okay, what about a flat line, guys? A flat line indicates zero speed, or in another word, indicates a constant speed. Okay, so guys, let us have a look at this graph. This graph represents the distance line graph of what? Of changing speed, as we can see here. So the question is, using the data table provided, complete the graph for the all-terrain vehicle. Part of the graph has been completed for you. So guys, here at 0 time, the distance was 0, then the distance started to increase. It reached 10 meters at 1, then the distance, actually can see that there is no change in the distance until we reached what? Until we reached second 3. Okay, at 3 it start to increase, guys. So the distance increased to what? It increased to 30. Okay, so let's start answering this question together. So as we said, at 3 okay, it reached 30, actually not 20, so 30 meters at the 4th second. Okay, then later it increased to reach 50 at 5 seconds. So 50 will be this way. Okay, so guys, suppose at, for example, at 6 this object start to slow down, then what do you think? For example, the distance at 6 was let us say 40, for example. What do you think? How we can draw the line here, guys? It will be this way. So you can see here, for example, it will decrease, as we say, to 40 at 6. So the graph will be low, or the graph will look like this, guys. As we can see, we don't have a straight line, but instead we have sometimes there is increasing, sometimes there's the line is flat, sometimes there is increasing or decreasing in what? In the distances. So as we say it here, the line, when the line gets steeper, then the distance or the speed is increasing, while when the line steep less, then the distance is or the speed is decreasing. So guys, that's all for today. Thank you, and see you inshallah tomorrow.